Tôi xin phép được mời báo cáo viên cuối cùng của cái phiên buổi sáng năm nay, Phó giáo sư Minoru Ishifuro từ Đại học Y khoa Tokyo, Việt Nam. Now we would like to invite Professor Minoru Ishifuro from UST of Tokyo, Vietnam. We'll have a speech on 3D image creation technology. So please.
Xin chào. This presentation titled 3D Image Creation Technology. This presentation contents shown here introduce 3D presentation content about 3D image creation technology. Type and processing of 3D image processing. Use of 3D image. Application of a new 3D image. The items shown on the slide are required to create 3D image. Reconstruction image processing are important after imaging. Few 3D image are designed in one click. Therefore, the original image is most important for 3D image and its major progress. That the imaging condition and the contrast enhancement condition are suitable for purpose. Then type of 3D image. Display shown here currently is the most very commonly used volume rendering VR. Other are MPR, CPR, MIP, minimum IP, RaySum, two-dimensional display. There are virtual endoscopy, VE, and VGP, for observing the inside of the lumen. In addition, surface rendering SR was used until VR developed, but now this SR is used outside of analysis. It shows the whole flow of 3D processing. The processing flow, modeling to rendering is the flow of the 3D image processing. 3D data condition is basically reconstruction with 1/2 slice thickness as slice interpolation. 3D image consists of processing of thresholding, mapping, viewing, and shading. MVR can display any cross section as a two-dimensional image from 3D volume data. In this case, the MVR image is shown when the actual image is used as reference. A CPR is a method of the displaying a curved surface on flat surface, and it's possible to display it. The dental field is the same way as the panorama photography. In the heart region, the blood vessel surrounding the heart can be displayed on plane so that blood vessel information can be easily grasped. This is a MYP principle, parallel projection method with high CT value displayed on the projection screen. This is a minimum IP principle, a parallel projection method used to display a small CT value on the projection screen. MIP created from abdominal CT angio. CT is possible to create almost the same image as angio and avoid invasive examination. Distinguish between contraction agent, calcification of bone, metal, etc. to view tissue with high CT value. However, since there is no stereoscopic effect, there are demerits that the information of the overlapping portion is lost, so it's necessary to delete the portion with high CT value. The MIP and minimum IP of the head 3D angio are shown. The skull has been removed in advance. The left is MIP image showing the silver bright vessel. On the right, and substance with small CT value, such as the ventricle is projected and displayed. A volume rendering is virtual screen display method that makes use of space, and you can understand that three-dimensional effect and depth. MIP with the same data shown that there is no stereoscopic effect because that substance with high CT value is displayed on the projection screen. Images are provided according to each application. Shown MPR and RASAM image. When RASAM is processed by using the average value of value in the projection part as a signal value on that ray, it becomes an image like simple X-ray image. Since MPR is to display certain cross-section in 2D, that display contents are different even if they are in the same direction. Visualization of 3D image. The use of 3D image used for diagnosis assistant in area requiring morphological information, informed consent, surgical support, and analysis of emergency area and functional tests. The 3D image is the most suitable information for surgery or treatment by grasping the damage situation and the pathological condition position. It's also possible to display from the line on sight of the operator standing position. Shows the display at the time of diagnosis and surgery. The image when standing on the left and right side of the patient are different. The central 3D image is true front view of the patient facing the patient at the time diagnosis. 3D image are effective and standing pathological condition, it's difficult to refer to large amount of slice data and convey it in a report. However, by contrasting slice data into 3D image, it's possibly grasp the pathology. CT image developing injuries shown. CT image displayed in the real time difficult to understand the damage situation. (3D image display can display different image depending on the threshold value. This will allow you to quickly understand the situation of skin damage and fracture. This is displaying a 3D image observing the damage to soft tissue. This is displaying a 3D image that observing the condition of bone damage. It shows the difference, the opacity curve on the virtual endoscopy image with contrast CT. By changing the opacity curve, blood vessel and the tumor region on the mucosal surface can be displayed in detail. The opacity curve of the virtual endoscopy image is displayed as the basic downward sloping curve of the make tape and the maker tape plate can temporarily display a slight change in CT value due to the rectangular curve. You can observe it is a moving image by chemistry capturing image with virtual endoscope. Since the 3D image processing can also fusion data of different time phase, it's possible to create an image in which plane and contrast image are superimposed. 3D image of brain created from plain CT and 3D image of silver blood vessel created from contrast enhanced CT are shown. This shows 3D image for craniotomy. The necessary 3D information requires fusion 3D image of skull and the brain surface, silver blood vessel and the tumor or silver aneurysm. A simulated 3D image of clipping of silver aneurysm is shown. It requires that the doctor observe at the angle actual surgery or the same direction as the surgical field. You can watch video of surgical simulation of cerebral aneurysm clipping. (3D image of craniotomy simulation of meningioma is shown. The square frame shows the anatomy range. The bar hole determines the position to make a hole for opening the head. Veins are shown in blue, arteries in red, and the tumor in green. It may be imaged during surgery of recipient and donor who performed living donor liver transplantation with reference to 3D image. The 3D image is represented by collection of box cells. Therefore, the volume can be displayed at the same time by box cell count. This is simulation of living donor liver transplantation for a candidate donor. When donating the right lobe, the donor should be transplanted so that residential liver does not fall below 35%. This case remains in 40.7% donor. We have confirmed the from after cochlear implant surgery with 3D CT. You can see in the 3D image that the lead wire can be inserted into the cochlear. Since the 3D image can be grasped three-dimensionally, the case of fracture, it's possible to support the reduction method is this humerus fracture. A treatment storage can be also determined for complex fracture of the right femur. Specimen image information can be provided even in the subsequent follow-up. Ganglion often repeatedly and often can be cured by suction treatment. But this case is a 3D image when it really removes incision. MRI examination is mainstream for soft tissue, but it's currently impossible to replace it with 3D image. It became possible to grasp the rupture from the CT data with 3D image. A 3D CT which can express various images depending on the threshold value can freely create skin, ligament, and bone. In this case, the injury site was temporarily treated due to traffic accident. But the 3D image showing several rupture of the flexor tendon was introduced due to inadequate finger flexion movement. Total hip arthroplasty is a procedure replace joint deformed by osteoarthritis, rheumatoid arthritis, femoral head necrosis, fracture, etc. with artificial hip joint made of metal, ceramic, porcelain, etc. We radiologists need to know about this surgery as well. As 3D data is almost recalled when performing total hip arthroplasty. It's also possible to plan artificial hip joint surgery from 3D image. You can consider the size by fusing the pre-operating CT data using artificial hip joint data that has already been replaced by other. The case where the right hip arthroplasty replaced is a 3D image video of the simulation of the right hip arthroplasty by fusion to perform the hip arthroplasty on the left as well. Emergency room. Facial trauma. The condition of the damage can be understood to some extent from the CT image, but there is little detail and information about the fracture. Also, 3D CT can understand the cerebral fracture of the facial bone. Is almost impossible to understand the fracture part because of the because other bone overlapping in front of X-ray image. The same applies to side image, even in direction of the right temporal medulla joint, it overlaps X-ray image. Penetrating trauma caused by metal pieces is a situation where damage is not clear due to occurrence metal artifact in CT. But in 3D, the position of the metal piece can be confirmed by creating metal pieces and bone. CT image shown some brain damage due to artifact, but the extent of bleeding are little understood. The relationship between the metal pieces and the brain can be understood from the 3D image. After creating 3D image shown over, observe the required angle. A fusion image can also fuse with different modality for the enhancing amount of information. The fusion pulmonary blood flow scintigraphy and chest 3D image of case of pulmonary information is shown. fusion primary, perfusion scintigraphy, MAA, and chest 3D CT image in lung tumor. Myocardial scintigraphy and 3D CT fusion. Cerebral perfusion scintigraphy, IMP, and 3D CTA fusion, cerebral infarction. Three-D volume rendering image of cervical spine, C2 tumor region are shown. From now on, it will convert it to virtual reality and data and display in space. Virtual reality can refer to 3D image in real space, converting the 3D image processing to standard triangulate language, STL, and attaching HoloLens. They are especially used in surgery. This is a video of virtual reality that actually used during surgery of cervical spine tumor case. HoloLens also has ability to capturing image. This presentation content conclusion shown here. Three-dimensional image are indispensable image for surgery, treatment, and IVR other than damage, and is necessary to integrate the knowledge and the technology that the greater image. Interpretation of ability and the pathological condition image information in more detail. One of them is utilized fusion image processing by fusion layer, etc., which is very useful information. Most of the 3D image introduction are created by RT in Japan. I wish today's presentation is helpful for you. Thank you.
Yes, thank you very much, Professor Ishifuro, for very interesting presentation on the 3D image creation technology and different clinical application. So once again, thank you very much.